All right, good morning, good morning, good morning. Welcome, grade 10s, to Thursday's Physical Sciences lesson. And now I just noted that in the chat we have Rutendo from Ferndale High and we have Rutendo from New Millennium College in Kempton Park. Oh my goodness, this is going to be interesting. Sure. Right, welcome guys. Very, very glad you are joining us. Who else did I see that was new? Can't find your name right now. I do apologize. Thank you so much for joining us, and I hope you learn a lot. And to my usual peeps, welcome, welcome. The class is quite small this morning. Erin, that is true. Erin, I haven't seen you in forever. What have you been doing, dude? Arthur's here, Ash is here, Braden's here. Braden didn't oversleep. Fantastic. Okay, all right, guys, let's get working. Are we all ready to do this? And in the last 5 minutes. Okay, Erin, I get that. Okay, so the last 5 minutes, guys, we'll spend just on chatting and touching base and making sure everybody's happy and comfortable. So in the chat, there is the Google Drive link. So everybody who hasn't been here before, in that Google Drive, you will find all the PowerPoints and a lot of worksheets of the work that we have done already. Braden's nagging me about the Lewis dot diagram. Braden, do you have any idea how difficult it is to explain Lewis? Right. I saw that, Corley. I got a wink, wink, nudge, nudge. So I fixed it. I hope it's better now. Okay, guys. So today we are going to look at ion exchange reactions. Yesterday, we started looking at ion exchange and we explained the two different types of reactions, right? And I'm just going to touch base on that again. You know me, I like to remind you of things. All right. And then we're going to look very specifically at ion exchange, more specifically at precipitation reactions. Okay, guys. So I haven't put a lot of work on for today because I know traditionally this work is quite tricky. So let's have a go. So we're going to look at ion exchange reactions today, very specifically at precipitation reactions. Don't panic, new word, I will explain it to you. Right, so if you are using the Oxford Successful Grade 10 Physical Sciences textbook, you'll find this on page 188. If you are using the Study and Master, someone corrected me yesterday because I thought Study and Master was like 216 for yesterday's, and someone said, no, we're looking more at like 270. So I have a suspicion that precipitation reactions is going to be somewhere on page 219. Might be a little bit before that, might be a little bit after that. You guys know, if you see it in your textbook, remind me, tell me where it is. I make a note and I correct the slide going forward. And then, yes, Corley Marie, it is Ionisasi. Whoo! My Afrikaans this morning. So it is roundabout there. I think for the Afrikaans and the English textbooks, it might also be slightly different, guys, which is why this is so flippin' hard to do, nah? Okay. Then, Doc Scienza. Again, there's like various books. I don't know if there's one set that's just one book or one set that's two books. I'm not quite sure why we end up getting different page numbers the whole time. Yesterday, I think it was Misty who said to me, ma'am, it's around about, yesterday's work was around about 234, 235-ish. So I am assuming that today's work is going to be round about 236-ish. Now, for those of you who use DocScienza or don't. Okay. I left Miss P a little present in the drive because I know sometimes it's a little bit hard to find these things. Okay. For those of you who do not have textbooks, please do yourself a favor. Download Snaplify with 2 P's. Snaplify. And you can then download a whole bunch of textbooks for free. Okay. So what a lot of companies have done, Oxford is one, Study and Master is another, and the Mind Action series. Oh, thank you, Tino. I will add that page as well. So the Mind Action series, the Study and Master, and the Oxford, those are all free on Snaplify at the moment. Yes, the teachers guys are free too. Don't cheat. All right. So now we have textbook pages. Let's get going. So this is recap from yesterday. Yesterday, I told you guys there are 2 big types of reactions. If we have to put all the reactions in the whole wide world, we have to organize them. Then we have 2 big folders. The one folder is ion exchange reactions, and that's where positive and negative ions change places. Okay, so they make new friends. Then we also get oxidation reduction reactions, redox reactions. Apologies for the puppy. She seems to have jumped off the bed and is making her way down the corridor. Anyway, so oxidation reduction reactions, redox reactions. Okay, and this is where electrons are transferred. Yesterday we had quite a serious discussion about the difference between an electron and an ion. And Braden, I will, when I do your Lewis dot diagram little video and notes to go in the drive, I will also again do that one where we spoke yesterday about the difference between an ion and an electron. Right. So these are the 2 big groups of reactions. We are going to focus today on ion exchange. Miss P! No, my goodness, you haven't missed much. We are going to focus today on ion exchange reactions, okay, specifically precipitation reactions, and oxidation reduction reactions, so redox, is going to be on Monday. Okay, Tyrese is also late. It's okay, guys. Like, I think it was yesterday when I barely got out of bed. We have a Toriso in here, which is a new name. Oh, Tyrese has just come. Don't panic. He's just popped in. Nelly's here. Larissa's here. Ooh, Joey, I haven't seen your name before. Israel, who was new yesterday, was here too. Oh, Shanae Gavender, she's new too. I'm supposing Shanae is a female name. I apologize if it's not. Aaron's a boy name. I got corrected quite quickly with that. But Aaron, I like Aaron's name. Aaron's cool. Okay. All right, guys. So let's get going on ion exchange reactions. Okay. Right. So ion exchange is when positive and negative ions swap places. Okay. Now, yesterday, again, we said there are 3 types of ion exchange reactions for grade 10. This doesn't mean that there's not more, but this is what we are focusing on in grade 10. So precipitation reactions, which is what we're going to do today. Gas forming reactions, which is a tiny little unit. We did that yesterday. And then acid-base reactions, which is all revision from grade 9. Okay, I know yesterday the slides I had basic stuff on acid base, and then there were quite a number of you who said, look, ma'am, like we're not quite sure about this, and we went onto the whiteboard. So I'm busy at the moment just fixing yesterday's slides with more information on acid base reactions for you, and Yesterday, we had quite a serious conversation about pH as well. And there were a little bit of, not confusion, but unsurety about the pH scale. Okay, so I've adapted yesterday's slides to include the conversations we had yesterday on both pH as well as on the different types of acid-base reactions that I'm going to expand quite a bit. All right, just so that you guys know why the slides might look different when you get them in the drive than they did yesterday. All right, so here we go. Precipitation reactions. Yesterday we said that a gas-forming reaction, the driving force is forming gas. So does anyone want to take a guess what the driving force of a precipitation reaction is? Come on. Does anyone want to take a guess? What is the driving force of a precipitation reaction? Erin was faster finger first. Erin said forming a precipitation. Erin, that is 100% correct. And I know it sounds stupid, okay? But it is something that you need to keep in mind. So the driving force of a precipitation reaction is the formation of a precipitate. Okay, what is a precipitate? It is an insoluble solid that forms when a reaction recurs in solution. So imagine I have sugar water and salt water, okay? They are both solutions. Can't see the sugar, can't see the salt. I know it's there because I dissolved it in that solution, okay? Now imagine I throw these two solutions together and suddenly a solid forms in the new beaker. That is the precipitate. All right, so it's very important. I need two solutions, so two things that is dissolved normally in water, aqueous. I add them together, and one of the products that gets formed, sometimes more, but most in grade 10 we work with one product. One product that forms is a solid, okay? And no matter how much I stir, no matter how much I shake, I heat the thing up, that precipitate does not dissolve again, okay? So that is the idea behind a precipitate, right? So we can write equations for precipitation reactions in 3 ways, okay? Now I put these down in words first, and then I'm going to show you how each of these follow on the other, okay? So just keep that in mind, that there's much more than just the wording, but I want to give you guys a broad overview of the 3 reactions, how we write them, before I show you how we write them, because they follow one onto the other. Okay, so the first one is we show all the reactants and the products, and then we use a downward arrow to indicate that a precipitate has formed. Okay, so next to the thing that is the precipitate, we make a little downward arrow to show that that thing is the solid. Does anyone want to take a guess? What else can we do to show that that compound is a solid? Think about the state symbols that we've been using. Oh, no one. Think about the state symbols we've been using. We've been using G for gas. We've been using L for liquid. We've been using AQ for aqueous, which means dissolved. And we've been using good Corley and ACE to show that it's a solid. Good, Tyler. So we can put a bracket and an S and a bracket after the compound to show that thing is a solid. Okay, I will show you both ways when we do these actual equations. Right, so the first one is I just write everything down. All the reactants equals all the products, and I put my state symbols in, and there you go. Now, the second way to do it, which looks really confusing if you just have this way of doing it and you don't realize what comes after, is to write each of the reactants as its ions and each of the products as its ions, except the precipitate. I will show you what this looks like. Don't panic. Okay? And when we write things like this, when we show the ions, it is easy for us to then be able to see the ions that cause the precipitate, which then brings us to this third type of equation. Okay, now this last equation, only showing the ions that cause the precipitate, is referred to as the net reaction, NET, net reaction. And what we use, or how we say it, is we say that the net reaction excludes, doesn't include, excludes the spectator ions. Sure, ma'am, whoa. So let's look at those two definitions. All right. The net reaction is a reaction that only includes ions that take part in the reaction. So for a precipitation reaction, we're only going to write the ions that cause the precipitate, which means we exclude the spectator ions. And the spectator ions are the ions that do not take part in the reaction. Now, I know this is a bit weird. I know you're going, but hang on a second. Everything I put in always has to be everything that I get out. That's the entire point of balancing. I get that. I agree. Sometimes, however, there are some things in the reaction that kind of just bounce around from one place to another. Okay? We see this lots with acid-base reactions. All right. In an acid-base reaction, the things that make the acid-base reaction, Erin, I see your question. I'm going to answer it now. The things that make it an acid-base are the OH and the H. They make water. That's your net reaction. Now, Erin's question is, are spectator ions a little bit like catalysts? Oh, that is a hard question. It's a very good question, Erin. The answer is no. A spectator ion is not a catalyst. A catalyst is a complete substance that helps the reaction take place, but you can get it out exactly like you would after. Larissa, good. Spectators, like, they watch and they don't participate. So guys, let me show you how we figure out what is spectator ion so that you can have an idea of like what I'm talking about. Okay, right. See, I said, don't panic. I forgot I wrote that. Huh. Okay, here we go. So the complete reaction. Now guys, I used the same example all the way through. The example I chose to use was potassium iodide, which is dissolvable. It is an aqueous. It is dissolved in water. And silver nitrate. Get used to silver nitrate. Start loving silver nitrate. You're going to use it a lot. Okay. This is an ion exchange reaction. So the nitrate and the iodine swap places. And I end up with silver iodide, you see there, iodide, silver, silver iodide, and potassium nitrate. There it is. Okay. Now, don't panic. I will teach you this. Silver things are all non-dissolvable except for silver nitrate. All nitrates are soluble. Okay, all nitrates are soluble. Silver, what is really cool about it is when it bonds. Okay, sure. So all nitrates are dissolvable. It is a rule. Don't worry, I will give it to you. All nitrates are dissolvable, except for nitrates. All things that bond with silver are precipitates. Right? I'm going to say that again. All nitrates are dissolvable. All of them. Like every single flippin' one of them. Most silver things do not dissolve. And the nice thing about silver compounds is they have very distinctive colors. So it's really, really cool to use silver nitrate because then you have a really good idea of what ions you have. Okay. So this is the complete reaction. Everything that I put in and everything that I get out. Okay. Now we are going to write this as ions. Okay. So look what happens to potassium iodide. It's potassium and iodide. You see that? I didn't change what I have. I just split potassium iodide into its ions. So it's potassium and iodide. I did the same thing here, silver. Silver and nitrate. Okay? Now, the second that I get a precipitate, there we go. The second I get a precipitate, I cannot split it into its ions. Because when I try and dissolve this thing in water, it's not going to split in its ions. That's why it doesn't dissolve. The reason why potassium iodide, I can write it as its ions, is when I do put it in water, it literally dissolves and it becomes these two ions. Remember, guys, that is why we call it an electrolyte. That is why water conducts electricity, because it has ions in it. So here you can see I don't split this thing into its ions because it doesn't exist as ions. It exists as a solid, as a precipitate. But because potassium nitrate is dissolvable, I can write it just like I wrote the other two. Right. Before I carry on, take a guess. Take a guess. If it's right, I don't care. If it's wrong, I don't care. I want you to take a guess. Which two things in this reaction do you think would classify as the spectator ions? Which two things? Which two ions do you think classifies as the spectator ions? And if you don't know, say, Ish, I have no idea. Israel went potassium and nitrate. Anyone got any other ideas? Anyone agree? Anyone disagree? Aaron's got potassium. Misty says silver. Ben says silver and iodine. Camilla says he has no clue. Cordley says iodine and silver. Nitrate and iodine, Larissa. Okay, so we all look at it and go, maybe that, maybe that. All right, let me put you out your misery. If I have a precipitate forming, then this precipitate is the driving force of this reaction. Okay? And so I want to keep this precipitate, okay? It has to stay. This precipitate must be part of my net reaction, okay? So silver and iodine is the driving force of my reaction, and so they have to be part of my net reaction, which means that potassium and nitrate, the two ions that are still in solution here, they are known as the spectator ions. Can you see over here, potassium was in the solution, nitrate was in the solution. Potassium is still in the solution, nitrate is still in the solution. The iodine in the solution and the silver in the solution, they found each other. They went, hey, I like you. We form precipitates. We are friends. Okay? And so they form bonds. Yes, Erin, the ions that do not form a precipitate, they are the spectator ions. Okay? So the ions that do not cause the precipitate to form, we can see them here at the end, and we can go and find them at the beginning. And they are known as spectator ions. So when we remove them, we have the net reaction left. So this is my complete reaction in ions. I'm now going to remove potassium and remove the nitrate. And so my net reaction is the iodine in solution, the silver in solution, and the two of them then form silver iodide. Sorry, sure. Chemistry brain's not awake yet, clearly. Okay, guys, that is very important for you. Okay, so if you ever ask for spectator ions, they're the thing that stay in solution. They're like happy-go-lucky. They're like, cool, look, those guys are reacting. We don't want to react. We're good. Okay, so you go find the things. Ashley, the potassium, can you see at the end? Just look at the complete reaction in ions. Can you see the potassium and the nitrate are both still in solution? Okay, and so they are spectator ions. They don't take part in forming the precipitate. So I call them spectator ions. And so when I write the net reaction, I do not write the spectator ions on either side. Remember, guys, what I have on the left, I have to have on the right. Okay? I can't create matter. I can't make matter disappear. So when I write a net reaction, I'm only interested in the ions that end up giving me that precipitate. Is everybody okay with that? Man, they have to be in the same group. Not necessarily. Come on. We're just talking about the things that, come on, the good trick that I can give you is once you've had your reaction, you look at the thing that's still dissolvable. And the ions that are still dissolvable, those are spectator ions. So those you can throw away. Okay. Ultimately, your net reaction, what you start with is what you have to finish with. Okay. Right. So, we have a number of uses for precipitation reactions. Most of these you do not need to know, but I thought it was interesting to tell you, okay? Because if you like being very precise, like to the drop, to the milligram precise, then this is actually stuff that you will find very interesting. Okay, I did this when I was at university. Tyrese, were you like out? No. Okay, so I did this at university. It was my favorite chemistry. Okay. Larissa, I am going to give you more examples. Don't panic. When I do the table with you, I will give you more examples. And what I'll also do is I will put more examples in the drive for you guys. Okay. Right. So, uses of precipitation reaction. We can use them qualitatively. Big word. Qualitative comes from the word quality. Okay? It means that I can identify which ions. Okay? So using precipitation reactions, if I have two solutions and I go, hey, is this got potassium in it? Has it got sodium in it? Has it got iodine in it? Has it got chlorine in it? We don't know. I can use precipitations, and by judging the reaction, what color forms, if I add an acid, does it stay a precipitate or does it dissolve? I can identify which ions I have in solution. And this is something they use in water analysis. So when you have a borehole or you have a new water source and you need to make sure whether or not the water is good to drink or bad to drink, whether or not there is heavy metals in the water, etc., etc., etc. You use precipitations to figure out what is in the water. Zalnay, no, this is actually term 3 work. This is like the beginning of term 3 work. Okay, so we can figure out which solutions are there. The other thing we can do is we can do quantitative, quantity, number. Okay, so now that we know what ions we have, we can measure how much of an ion we have. Now, guys, if you haven't put 1 and 1 together and gotten 2, this is how forensic scientists figure out, is these two samples the same? What is in these samples? And what can I gather? What can I figure out from these examples? So forensics has so much in it, guys. Like, it is such a wide field. But I really loved chemistry. And I loved analytical chemistry. This figuring out, this, how much of this is there in it and how much is that, and how pure is it, etc., etc. Okay, so if you enjoy being finicky, investigating, you know, liking a challenge, I really, really encourage you guys to have a look at analytical, so analysis, chemistry, and how that relates to forensic scientists. Okay, and it's not just forensics where you use it, you can use it anywhere. All right, so this is not grade 10 requirements, okay? But I think if you understand why we do precipitation reactions, then it makes more sense, because they are a little bit tricky. There's quite a lot to them. Corley says she wants to go do Forensic science in Germany. I like that. If I wasn't a teacher, I would have been a vet. And if I hadn't found teaching, which was an absolute accident, if I hadn't found teaching, I'm pretty sure I actually would have gone into forensics. But I am very happy that I am a teacher. Couldn't imagine my life any other way. Okay, so now let's get to the stuff that you need to know for grade 10. Miss P, I think I've told you guys that before. I'm a bit of an open book. You guys need to know who I am because you don't ever see my face. You don't see me as a person. So if you don't know who I am, then that's not quite fair. Hey, Tino, when we get to the end of the lesson, we can answer that, okay? Because that is a very fair question at this point. So for grade 10, you need to know that precipitations are used to manufacture chemicals. The one that I saw in the Oxford was calcium carbonate, so limestone, okay? They use precipitation reactions to make chemicals. And the other one, okay, that we don't investigate but that you have to know about is that we can remove unwanted substances. So if we know we have something iodine in there, something iodide, and we want to remove it, then we can add silver nitrate, we get the precipitate, and then we can remove the precipitate relatively easy from whatever we're dealing with. Now, the big thing we use it in grade 10 for precipitation reactions is testing for the presence of dissolved ions. Okay. Now, the reason we do that, guys, sodium chloride, nondescript white crystal. Potassium chloride, nondescript white crystal. Sodium iodide, nondescript white crystal. And the amount of times I've walked into school labs and there's a bottle, it doesn't have a label on it, and I open it and it is a nondescript white powder or crystal, I cannot tell you, okay? And because it doesn't have a label on it, we have no clue what's in there. So you can use precipitation reactions to figure out, okay, is it a chloride, is it an iodide, is it a bromide, is it maybe a sulfate, is it maybe a nitrate? Okay, so we use precipitation reactions, and the focus in grade 10 is to figure out what is in that solution. Okay, now the next table I borrowed from the Oxford Successful. Okay, I will take this table, and I think Larissa asked for a couple, or Ashley asked for a couple more examples. Who did? Larissa asked for more examples. Okay, so what I'll do is I'll take this table that's coming up and I'll show you step by step examples. Okay, so here's the table. Don't panic. It's not as bad as it seems. Okay. So we start on the left. It's okay, Gordley. Okay, we start on the left. If we want to test for sulfate ions, okay, we add barium nitrate. I'm going to simplify this whole thing for you, okay? I promise, but you need the whole big table. Miss P, calm. Okay, I will simplify this table for you. I know it's a lot. Kamal, you don't have to screenshot it, dude. Go to the drive and get the slides. Okay. Yes, Tyler, I promise I will simplify this for you. I promise. But I need to give you guys the big picture. okay, and explain the big picture, right? And then I promise I will simplify. So let's have a look. If I want to test for sulfate ions, so I want to see, is there SO4 ions in there? I add barium nitrate. Barium nitrate. Okay, don't worry too much about the balancing of this whole thing. Barium then likes to bond with sulfate, okay? And barium sulfate is a precipitate. Okay, right? So if I want to know, do I have sulfate ions? I add barium nitrate. I get a precipitate. And if I add dilute nitric acid, it's just a double check. You don't actually have to do that. If I add dilute nitric acid, I still have the precipitate. Okay. Normally, when I'm testing for stuff, I like to start with silver. Okay. But it is always safer to start with barium nitrate, because barium chloride, barium bromide, and barium iodide are all dissolvable. Okay, so if I add barium nitrate and no precipitate forms, or a precipitate forms and I add nitric acid, I'll show you guys that one now. So if I have a solution and I add barium nitrate and no precipitate forms, okay, then I know that I'm most likely dealing with chloride, bromide, or iodide. Okay. So if I don't get a precipitate, then I add sodium nitrate or silver nitrate. Okay. If I add barium nitrate and I get a precipitate, but I add nitric acid and my precipitate dissolves, then I have a carbonate. I'm going to reorder this thing for you guys as well, because jumping back and forth is a bit weird. Okay. Yes, Tyrese, there is a big book of all the chemical tests. I've got it in my varsity textbook. What I'll do is I'll copy and paste it for you. Okay. So if I have silver nitrate, let's say calm. I know. We will go back to this on Monday first. I know how hard this is. I'm going to simplify this table for you, okay, with step by step instructions, okay. Miss P, I don't know. I'll have to check for you. All right. So guys, I'm going to simplify this table for you. Tomorrow we are Kahooting, right? So let's have a look at what we're doing tomorrow. So you guys know the tags, nah? Use them, abuse them. So Friday we're doing a Kahoot. Monday, and we're doing it on chemistry revision. So term 1 and 2 work, guys. Okay, so easy chem. Easy chem. Right, so covalent bonding, ionic bonding, metals, non-metals, metalloids, semi-metals, stuff like that. Okay, we're Kahooting that tomorrow. Then on Monday, I'm going to start with the precipitation, make you a bit calmer about it. Then we're going to look at redox reactions. So here's the link to the drive. I have put it, and I will put it again in the chat. Okay. All the resources are in there. Okay. I will also turn the slides into Word docs, so it's easier to download and print if you want to. Okay. Erin, don't panic. The guys who has played Kahoot before says that don't get the app, rather use it on your browser. Okay. Today's YouTube link is there. If you need to go rewatch, please do. Don't panic. Okay. And then my email address is here. This slide is in the drive, so you don't have to write down my email address like a mad thing. We are from next week. Brayden, calm. Oh my goodness. From next week, we are going to start doing like mini assessments, not for marks. Oh my goodness. Okay. But I want to see, did I help you? All right. Cool. So you guys know the drill. African Teen Geeks, abuse it, use it. Tino, the last couple of seconds, you asked me if it's very stressful being a teacher. It depends on the type of teacher you are. I think I take my job very seriously. I think it is very important for me to explain things to you as best as I can. And if I don't explain it to you in a way that you understand, I need to go back and think about it again. Currently, I think teachers are experiencing a lot of stress because we are worried that you come to school and we miss someone who has the virus for whatever reason, and then we make a lot of other people sick. I don't think we're worried about the legal stuff. We're worried about what does that mean for me. Okay. So yes, it can be stressful, but you know what? It makes me very proud when someone goes from getting 60% to 80%. Okay. And that to me is worth it. Yes, Miss P, I think we have big hearts. Right, guys, I will see you guys tomorrow. We're going to Kahoot. Don't panic. I will hold your hand if you haven't done it before. And next week, we're gonna be okay. It'll be cool. Bye, family. Have a fantastic